We have with us today Kamal Shwaik, who is an aeronautical engineer at Boeing. Could you tell us a little bit more about what you do?
I'm an aeronautical engineer and I manage the flight dynamics and control group at the research part of the Boeing company. It's called Boeing Research and Technology, and it's a relatively small team of aeronautical engineers responsible for the design of aircrafts, especially advanced aircraft. That's the aerodynamic design as well as the flight control design. So it includes the software, the control systems, the flying qualities, and the stability and control of the vehicle.
Yeah, I understand you've been working, you yourself personally have been working with the blended wing design, such as this X-48C that we have the model here. What are the benefits of having this blended wing design?
The advantage of the blended wing design, and if I can just show this to the camera, this is what the blended wing aircraft looks like. So it's quite a bit different from a traditional aircraft where you have the wing and tube. In a traditional aircraft configuration, the wing is what produces the lift. Everything else, the tube or the fuselage, which houses the people and the equipment, and also the tail, that is typically they don't produce lift, but they're more of a drag generation components. So that's really unfavorable. You don't want an aircraft with a lot of drag. So the blended wing body does away with the typical fuselage, and what it really does is, as the name implies, it blends the wing with the fuselage. So this whole configuration, everything here generates lift, unlike the classical configuration of the wings and the fuselage where only the wing produces the lift. So it makes it quite a bit more of an efficient design, and there are some estimates that have shown this particular concept to produce up to 30-35% less fuel usage than a traditional equivalent classical aircraft. So that's the main advantage.
Okay, I know while you're working on this project you had three different designs. You had the X-48A and the X-48B and the C. And I know the A was never actually put into flight, but could you describe the differences between the X-48B and the X-48C?
Right. The A, as you mentioned, was just a concept that never really saw flight. However, the B and the C are similar in that they're both remotely piloted vehicles. And by that I mean they're actually flown by a pilot who's sitting in a ground control station on the ground with the screen and controls, all the traditional controls, flying the vehicle remotely. The vehicle itself is about 21 foot in span, so that's from this point to this point. It's about 500 pound vehicles. The B started with the 3 engines, and they're jet-capped P200 engines. Each engine produced about 54 pounds of thrust, so you had about a total of about 162 or so for the whole aircraft. We flew that configuration, and the main objective of that project was really to prove that these type of configurations, advanced configurations, which are inherently unstable, can be controlled in flight and can be made to fly just like a classical configuration. And we have proved that with the B. The C, however, we went a step further and we altered the configuration to show benefits for noise reduction. That's why we brought the winglets from the B inward to the C, as you see them here. So you've got the verticals further in, and the reason for that is to shield noise from the engines. We also went from 3 engines on the B to 2 engines on the C, and these are AMT engines that produce about 90 pounds of thrust each. So we've improved the power or the thrust level for the C, and also we were able to extend the flight duration from the B to the C by a few minutes. And these are typically, because it's a small configuration or aircraft, because it doesn't have that big of a fuel tank, it only lasted about 30 to 35 minutes for each flight.
And how will these blended wing designs be applied, whether it be commercial or military? What do you see this design going in the future?
Well, initially it was envisioned actually for both, that it could carry commercial passengers as well as used as military applications, but more recently it's being directed towards military applications. It can be used, for instance, as a tanker, it can be used as a cargo aircraft, So it had a lot of usage or even surveillance. Right now we are talking to the military and trying to see if they have interest in a full-scale configuration like this. Which interestingly also, I talked about the control surface, but this particular configuration has 20 control surfaces all at the tail right here. And on the aft part of the aircraft as well as on the verticals. So so with that number of control surfaces, you get a little bit more maneuverability and versatility in controlling the different modes for the aircraft, whether it's pitch, roll, or yaw, or a combination of all those modes.
All right. Well, thank you for your time. We've learned a lot from interviewing you.
You're welcome.